This is 50 challenging problems in probability. I do recommend before you watch this video, go back and watch the last video I just made because this problem kind of builds off of that same idea. It's not necessary, but this problem kind of references the last problem. But this problem is called Twin Knights. It's number 17, and it has two parts, A and B. I won't be going over B in this video, but I'll post my work for B after this video because it kind of just took me a while and I don't want this video to get too long. Suppose King Arthur holds a jousting tournament where the jousts are in pairs as in a tennis tournament. The 8 knights in the tournament are evenly matched, and they include the twin knights, Balin and Balan. What is the chance that the twins meet in a match during the tournament? So here's what the bracket looks like. I like to substitute the names because Balin and Balan are just gonna kind of drive me crazy. So let's call Balin twin A and Balan twin B, right? It doesn't really matter, but this is just what I chose. So we want the probability that they meet in this tournament. I think the best way to solve problems like these is fixing one twin. So say we fix twin A. There are only 3 possible rounds in which the twins could ever meet, right? The quarterfinals, which is this round, the semifinals, which is this round, and then the finals. And those 3 events are solely determined by where twin B starts if we fix twin A. So what is the probability that the quarterfinals is the possible meeting round? Well, if we fix twin A, out of the 7 other possible positions where twin B can be, the probability that the quarterfinals is the possible meeting round only happens if twin B is here. So 1 out of 7 positions. Now we want to find the probability that the semifinals is the possible meeting round. Well, that only happens if twin B starts in any of these 2 positions. And then if the final is the possible meeting round, that happens when twin B is in the other half of the bracket. So with 4 possible positions. So now, given the round, what is the probability they actually meet? So suppose B is in a position where the twins could meet in the quarterfinals. What is the probability they actually meet in the quarterfinals? Well, if B is here, the probability they meet is 1. Like, they're meeting, they start off together. Okay, that was pretty simple. Now, what's the probability they meet given the possible meeting round is the semifinals? Well, what does that mean? It means that we need A to win, and we need twin B, which is in any of these 2 positions, to also win. And because both of those are independent, and a win comes with 1/2 probability because it says everybody's equally matched, we can multiply those probabilities together. So 1/2 times 1/2 to get 1/4. And now suppose B is in a position where the twins would first meet in the finals. What's the probability they actually meet? So if B is in any of these 4 positions, A would need to win 2 games, and then B would also need to win 2 games so that A and B can meet in the finals. And each win is 1/2 probability, so you have 1/2 times 1/2 times 1/2 times 1/2, which in turn would be 1/16. Okay, so we have all our probabilities. Now let's finally compute the probability of them meeting. Because we know conditional probability works this way, we can kind of also just think of this averaging over each of the possible starting positions of B. We can multiply and add these together, right? Right, so the total probability that meet is 1 times 1/7 plus 1/4 times 2/7 plus 1/16 times 4/7. We get 1/4. So the probability that these 2 twins meet in this 8-night tournament is 1/4. Thank you.